Okay, this homework is for chapter 3, homework number 9. We'll be working on number 101. Right, number 101 says write an equation for each situation below showing the area as a product is equal to the sum of the area as a sum. All right, excuse my reading skills, reading abilities. Right, so for each of these, you're gonna go ahead and basically find the sum, but you're gonna have to do a product of that. All right, so just go ahead and multiply 12x and x, you will get 12x squared. All right, and then you're gonna go ahead and multiply x and 1 to get 1x. You're gonna multiply 12x and -5 to make -60. Ooh, for some reason it's not writing. -60. Sorry, -60. Okay, I think my program is lagging a little bit. -60x, there it goes. And -5 times 1 is -5. All right, so that's completion of the area model. And directions is to write the area as a product and let it equal to the area as a sum. Okay, so as a product, so I'll write it right here, product. Yeah. So area as a product is going to be 12x plus 1 times x minus 5. Okay, and area, well, actually, let me make a little bit of space. I know it's a little tight, but here, plenty of space now. And area as a sum is going to be 12x squared plus, right? And then we notice that we have a 1x and we have a -60x, and we can combine those because they're both x's and they're both the like terms. Okay, they're both like terms. So in this case, -60 and a +1 actually will make a -59. And those are both x's and then just -5. So in this case, we have a product which is equal to the sum. Okay, that's the first one, or A. Okay. If you need time to write it down or think about it, pause it because I'm gonna erase it. Okay, B, and actually I'm gonna take out A so I have a little bit of space. Okay, so for part B, we have another area model which we can complete. So 3m times 2m squared would be 6m to a third, because there's m squared and another m makes m to a third. 3m and -4m makes -12m squared. And 3m and -1 makes -3m. Okay, down below, second row, we have +5 and 2m squared makes a +10m squared. +5 and -4m makes a -20m. And +5 and -1 makes a -5. Okay, so we're going to go ahead and write this out as a product. So the product is going to be 3m plus 5 times 2m squared minus 4m minus 1. That's your product. Okay, the sum is going to be all the stuff on the inside. Okay, and the terms that we can combine, we should combine. So for example, 6m to the third power, if you look at all these other terms, there's no other m to the third power. So I'm done with 6m to the third power. So I'm going to go ahead and just write down 6m to the third power. Okay, but then when I move on to -12m squared, you notice that there's another term that has a square, which is the 10m squared. So we can combine those. So -12m squared and +10m squared. So think about -12 plus a 10, right? So negative 12 plus a 10, they're different signs. So we're going to go ahead and subtract them. 12 minus 10 is 2. And we keep the symbol or the sign of the bigger number, which is the 12, which means we're going to keep the negative. So the answer is going to be negative 12. And then those are both m squares. Okay. Up next, we have the m. So we have a negative 3m. And then we notice that there's another term that has an m, which is negative 20m. And then they're both negative, so I just have to add them and keep the symbol or the sign. So negative 3m and negative 20m makes a negative 23m. And then lastly, I have my minus 5. And that is just a term or a constant term or a term that doesn't have a variable with it. And there's no other term that looks like that. So that by itself is going to be part of the answer. It's just negative 5. Okay. And again, the product is equal to the sum. Okay. That's the answer for part B. Again, if you need to take a pause the video. Okay. Because I'm going to erase all of that. Actually, I'm going to leave that. Okay. Moving on to part C. Okay. Part C, we have so we have this set up, and it's not an area model. You notice that it's not an area model. You could make an area model, or you could just do a double distributive property. Okay. So I'm gonna go ahead and start off with. I'm gonna start with just the area model because we've been working with area model. So notice that this is 2 terms. So I will need to have at least 2 things going across. And notice right here, I have 2 terms also. So I will need to have 2 things going up and down. So in this case, I will have a area model that is split into 4 pieces. Along the top is 2x plus 5. Along the side, and any side you can go with, is x plus 6. And you're going to go ahead and complete your area model by multiplying it out. So inside the area model, we have x times 2x is 2x to the second power. X times 5 is a 5x. 6 times 2x is a 12x. And 6 times 5 is a 30. And notice that this is already written. If you didn't notice, this is already written in the form of a product. Okay, this 2x plus 5 times x plus 6, this is already a product. So I just have to say, hey, that's going to be equal to my sum. Okay, which is going to be that 2x squared plus, and then notice we have a 5x and a 12x. They're both x's, so I'm going to combine those, and they're both positive, so I'm just going to straight up add those. Right, so 12x and 5x, or 12 plus 5, makes 17x, and then just plus 30 because 30 is just a constant term or the number by itself, which is what we have. Okay, so that's C. All right, I'm going to go ahead and if you need to pause it, but I'm going to go ahead and erase it. I'm going to go ahead and, so on D, just because, you've seen product, or not product, area models so much, I'm going to go ahead and do this with a double distributive property. And I seen some of you guys do this on, or try to do this on a test, but you guys have failed. Okay, because you're not doing it correctly. So if you're going to do distributive property, you need to do it 4 times. So first time is take 3 and multiply it to the 2. That gets you 6. Okay, then take the 3 again and multiply it to the positive y. You got to do it like that. Okay, and that's going to give you positive 3y. Okay, once you're done with the 3, now you're going to move on to the negative 5y. And you're going to take negative 5y and you're going to multiply it to the positive 2. So negative 5y and positive 2 makes a negative 10y. Then you're going to wrap up and go negative 5y times a positive y, which will make a negative 5y squared. And that's how you successfully do a double distributive property. Okay, now you got to combine like terms. So we're going to start off with the 6, and there's no other number that is just a plain number like 6 or 5 or 27. So we're just going to write down 6. Okay, and then Next thing we're going to do is we're going to combine some terms. We have a 3y, and we also have a negative 10y. Okay, those are both y's, so we can combine those. So positive 3y and negative 10y makes a negative 7y. And then last but not least, okay, we have just the term negative 5y squared, or the term with the square, the y squared. And notice that there's no other term with its y squared, so we're just going to copy that down just the way it is. Okay, and that's your final answer right here. Okay, notice that I actually wrote this a little backwards, and it's okay to write it this way. This is from smallest y, smallest degree to biggest degree. So we're going in ascending order. We're going from smallest to biggest. Okay, all the other answers that we've been doing for part A, B, and C, we've been going in descending order. Or starting with the square, and then doing the term with the one power, and then the term with the no power. Okay, so for example, this one we can also rewrite this as negative 5y squared minus 7y plus 6, and this would be okay as well, but this will be in descending order, meaning starting from biggest and working our way down towards the smallest. Okay, so this is ascending order and descending order, and we typically like to keep it in one of these two orders. It's technically not wrong to mix them around, but it's okay either way, right? Okay, number 102. Okay, calculate the following products by drawing and labeling an area model or using the distributed property. So the way this is set up, I'm going to go ahead and use the distributed property for the first two. So for A, I'm going to go ahead and do negative 4y times 5x, which is going to equal negative 20, because negative 4 times 5 is negative 20. Then x times y is just x times y. Okay, you can also write it as y times x, but it is customary to write it in ABC order or alphabetical order. Okay, negative 4y times positive 8y makes a negative. So negative 4 times 8 is negative 32. And then y times y is y squared. And that's about all. Okay, part B, we've got, again, it's only one term, so I'm going to go ahead and do distributive property. 9x times negative 4 is a negative 36x. 9x times a 10y is going to be, so 9 times 10 is a positive 90. And the x times y is just xy. All right. This last one, I'm going to go ahead and do an area model for this. Okay. And I noticed that I have three terms. So x squared, 3x, and positive 5. Okay. And then and then the other product is going to be x squared minus 2. And notice I didn't put the positive 5. I just put 5, but you could put plus 5. And there is no difference. Okay. There is no difference. Nothing wrong with putting plus 5 behind the 3x. Okay. But I just chose to put 5. And you can do it either way. Right? Just area model. So multiply it out. X squared and x squared makes x to the fourth. X squared and 3x makes 3x. And then you notice there's 3 x's. There's x squared and then there's another x. So that means there's 3x and then to the third power. Okay, x squared times 5, that's going to be 5x squared. Okay. X squared times negative 2 is going to be negative 2x squared. Okay. 3x times negative 2 is going to be negative 6x. And 5 times negative 2 is going to be negative 10. So that's what we get when we complete our area model. And we're going to go ahead and write down the sum, okay, or the answer to this. All right. So first off, you notice x to the fourth. Anything else has x to the fourth? Nope. So all we have is just x to the fourth. Okay. But as we move on to the next term, the 3x to the third, also notice that there is no other x to the third. So we're going to go ahead and just write down plus 3x to the third. Okay, and as we move on, 5x squared. Okay, you may notice that there's another term with the x squared. So there is another term with x squared, which is the negative 2x squared. And those we're going to combine. So positive 5 and negative 2, if we add them, it's going to make a positive 3. And they're both x squared, so that's our term. Okay. Our next term is going to be x. You notice that is our only term with the x, so that's what we're going to have. It's going to be a negative 6x. Okay, mine's hiding it a little bit. So minus 6x. And then our last term is with the minus 10. And that's all we got. Nothing else, which is a number. So minus 10 is going to be our final answer. Okay. All right. And backside. Okay, 105. While David was solving the equation 100x plus 300 minus 500, he wondered if he could first change the equation to x plus 3 equals 5. What do you think? Well, you know what I think. Of course he could. So, what do you think? I'm going to say yes, he can. Okay, change it. Okay, well, I know my stuff. Okay, I know my math, but for you, okay, we'll talk about why he can change it. Okay, part A says, hey, solve both equations and verify that they have the same solution. So solving is pretty easy in this case. To solve for this equation here, okay, all we have to do is subtract 3 from both sides, cancel or simplify, and then we're going to get x equals 5 minus 3 is 2. That's our answer for that simple equation. Okay, for this bigger, more complicated equation, we're going to do the same thing. Okay, we're going to go ahead and subtract 300 and subtract 300. When they simplify down to 0, we're going to get 100. X equals 500 minus 300 makes 200. Okay, now we're not quite done. On the other side we were done, but in this case we have to divide it both sides by 100 in order to solve for x. So 100 divided by 100 makes a big 1, and you get x as your simplified side. And then on the right hand side, you get 200 divided by 100, and we know that makes 2. So if we look at both our answers, yes. So of course he can change it to the green equation because they're the same answers. So that means that they are equivalent to each other. Right? So looking at part B, what could you do to the equation 100x plus 300 equals 500 to change it into x plus 3 equals 5? Right? So what you can do, or what I can do, or what we can do is we can take this equation right here and we can divide both sides by 100. So left side by 100 and right hand side by 100. And when we divide it by 100, it basically makes 100x plus 300. And because it's dividing by 100, each of these are dividing by 100. And on the right hand side, we get 500 divided by 100. Right? And if we look at this, 500 divided by 100, right? That's gonna simplify down to 5. 300 divided by 100 is gonna simplify down to 3, and 100 divided by 100x divided by 100 is gonna simplify to 1x, or if you like it better, just x. So yes, we can totally change this equation 100x plus 300 equals 500 to x plus 3 equals 5. Okay? Okay, that's your homework.